Hello Pre-Calc kids, welcome back to another lesson in AP Precalculus. This is Mr. Bean. Today's lesson we're going to look into the next part of conic sections, which is ellipses. And ellipses and circles. A circle is a special type of an ellipse. So to start us off, we're looking at these equations of an ellipse. And we have here, you've got H and K, which is going to stand for our center of the ellipse. We do this with lots of different things we've done throughout Algebra 2, Algebra 1, where you have this H and K. It's always the opposite, gives you the center. And then you have A squared underneath the X and B squared underneath the Y, and it always equals 1. And you have addition here. And it's going to always equal 1. So we have an A squared, a B squared, and it equals 1. So what do these numbers represent? A, if we took the square root of this number, that is the radius of the horizontal portion of the ellipse. So if we look down here, if this was the center of the ellipse, it would be this direction. A is that right there. That's A. In this case, it would also be A. It's the horizontal. It's the A that way as well. Now the B, this part of it, underneath the Y value, that is the vertical radius. So from the center of the ellipse, vertically up and down, that is a value of B. So in this case, it would be the letter B would be the vertical. Now you're going to see in textbooks, and most of the time what I've seen in textbooks is that they say whichever one is larger is the A. Right? So if whichever one is larger, the A switches back and forth depending on which one's bigger. College Board, what they say is, let's just leave it as A squared is always underneath the X and B squared is always underneath the Y. I'm pointing that out because some of your teachers and some of the textbooks might explain this a little bit differently. It still works out. It's still the same type of an equation. You're just switching which one's the A and the B. In this case, what we're going to do is just say if the A is larger, then it is a horizontal ellipse. The easiest way to remember this is just this. Ask yourself this question. Which one has the larger denominator? If the larger denominator is under the X, then it's horizontal. If the large denominator is here under the Y, then it is a vertical ellipse. It's stretched up and down. Okay, that's probably the easiest way of doing this. Okay, next up, definition of an ellipse. So the definition of ellipse is, it's kind of cool. It's not vital to understand everything that's going on with working with ellipses today, but it's still kind of cool. If you just put a point anywhere on the ellipse, in this case, I'm going to say an XY coordinate point right there, and then you draw a line from these imaginary dots, that is, this one's a focus, that one's a focus, together they're foci, plural is foci. So if you have two foci, they're imaginary dots on inside the ellipse, on the way to the vertex. So here's a vertex on the both left and right side. If you draw a line to that point from each focus and then add the distance 1 and distance 2 up, if you add those two, you get some constant value. No matter where the coordinate point is, if I put a coordinate point way over here on the bottom left, right there, and then I drew a distance from the focus like that, and I drew the distance there, and that is really bad, and then I added those two values up, you'd get exactly the same constant as if you had done it right here. Okay, so that is the definition of an ellipse. Again, you don't have to be able to calculate any of that when we're doing it. We're just telling you that that's how you know what an ellipse is. Okay, what we're doing is we're identifying how you find all of these points. So first, let's talk about the vertex. The vertex is how far away you are from the center to the edge of the ellipse. In this case, since it's a horizontal ellipse, this vertex, we would have to add A to it, right? The A is the radius from the center to the right. And so what is the coordinate point of the vertex? It is H plus A, because the center is at H comma K. So the vertex is H plus A comma K. And then if we went the other direction this way, you'd subtract the A. And so you'd have the center at H, subtract the A. And where's the A coming from? It's right here. It's in the formula. It's whatever this value is, and then you take the square root of it to get that. Okay, and then now, what about the focus? This is kind of weird. Okay, so focus is this. You take the two numbers, A squared and B squared, and subtract them. That will give you your C squared. Okay, the C squared tells you where the focus is. So watch this. You have from the center, you'd add C or you'd subtract C to get to the focus. That seems really, really confusing. It's not that bad once you practice it a little bit. It's just understanding how to find C. And C is kind of looks like this Pythagorean relationship a little bit here, right? Kind of like the Pythagorean theorem. There is some similarities there, but it's just always, notice how the a squared, b squared, they switch places. This is confusing, so here's what I would say. C squared is just always the big denominator minus the small denominator. That's what C squared is. And then once you take the big denominator minus the small denominator, take the square root, and you've got C, and that value of C is what you use from the center to find the focus. The foci, I should say. Okay, is that about as clear as mud? Here's on the next slide here, we've got nothing you have to fill out. It's just there for you as a reference. So a horizontal ellipse is stretched left and right. So you'd add A, subtract A, add C, subtract C. If it's a vertical ellipse stretched up and down, you'd be adding B to the K value, to the Y value, subtracting B to the Y value or the K value on this. Okay, and so there's other things here that you can look at to make sure you understand. So let's just put this into practice. Let's try one of these problems. So first off, we're gonna sketch the graph of this, identify these things, and then we'll put it on this sketch. So right off the bat, where is the center? The center is pretty straightforward. It's just the opposite of these two numbers. What's with the x and what's with the y? There's my h and k. So the center is at 1, -2. There's my center. Now, is it a horizontal or a vertical ellipse? The larger number is underneath the x. So it is horizontal. Okay, so in other words, it's going to be stretched like this. Okay, I'm just drawing myself a quick little picture just to remind myself it's a horizontal ellipse. So how do I find those points? At the end of the major axis, these vertices. So remember, the major axis is going to be a horizontal all the way across here. So from the middle to the right, that's a value of A. So what is A? Well, I know that this here is my A, that first one. So it is a squared is equivalent to 25. Take the square root of that and we get a equals 5. So what we're doing is we're adding 5 to the x value of the center. So we're adding 5 to this. What that tells me is I can say, well, the x value has to be 1, and I'm going to add and then also subtract the number 5. The y value is not going to change for the vertices here at the end of the major axis. So that's still going to just be -2. So my vertices, the ends of the major axis, are 1 - 5, which is -4, comma -2, and then the other vertex is at 1 + 5, which is 6, comma -2. Okay, let's start plotting some things on here that we know for this graph. So 1, -2 is where the 1, -2 is. This is the center. So we have the center of our graph, and then -4, -2, and 6, -2. Or I could just remember that A is a 5, and I could count. So if I wanted to just count 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then there's my vertices, or the ends of the major axis. And you can double check that those coordinate points are correct. All right, how about the minor axis? The minor axis will be this right here. It's the value of B. We're going to add B to get to the top and subtract B to get to the bottom of the ellipse. So what's B squared? B squared is 16. That's the y value there, underneath the y values. So 16. So therefore, B is a 4. And then that leaves me with, what am I doing? I'm going from the vertex, 1 and -2. X is not going to change. X is going to stay a 1. It's the y value that is changing. So y is going to change from -2, and I'm going to add and subtract the value of B. And there's the ends of the minor axis would be 1, comma, -2 - 4 is -6. And the other point would be 1, comma, -2 + 4 is a +2. If I do the graph, I just have to remember the value of 4. So I'm going to go over here and I'm going to add and subtract 4. 1, 2, 3, 4 to get to the top. 1, 2, 3, 4 to get to the bottom. Now the foci we don't need in order to sketch the graph. I will calculate out here the foci in just a minute. I just want to show you. So now how do we sketch the graph of this? If you're doing it by hand, it is pretty tricky. You just kind of like try to make it a little bit smooth and start to curve. Same here. This is how I would recommend you do it. You just take those points, the 4 points that you've created, and try to curve them. Now I'm going to cheat because I'm using a computer, and so I'm just going to use a drawing tool and create a shape. So I will create the shape like this, and that's really fast and easy for me because I'm cheating. And there you go. There's our ellipse. So that's what it's supposed to look like. Now, where are the foci for this thing? So the foci are at, remember this is where we use c. So we're going to have c squared equals the big one minus the small one, the small denominator. So what were those? They were 25 and 16. So c squared is equal to 25 minus 16. C squared equals 25 minus 16 is 9. Therefore, c is equal to 3. And so we're going to add and subtract 3 along the major axis. Remember, this is a horizontal, so we're going left and right. So 1, 2, 3. There's one vertex. 1, 2, 3. Vertex, I mean foci. So there's a focus. There's another focus. And those are the imaginary dots. Remember that if you take any point on the ellipse itself, any coordinate point along the ellipse, and you connected them, and then you added those two distances up, that would be a constant anywhere along the ellipse. So what are those two coordinate points? It's going to be -2, -2. So -2, -2. And then the other coordinate point was going to be 1, 2, 3, 4. 4, -2. All right, so now we've got our foci listed. All right, so all you're going to do next is I'd like you to try this one on your own. So do the next one all on your own, pause the video, see if you can work out from what we did with number 1, what the answers are to this one. And I'll have the answers appear here in just a second. So let's take a look at what you got. This one was actually a tricky one because it was a circle. Hopefully you recognized as you were working through this that it was a circle, that a squared and b squared, there's no difference between the numbers. So since neither one of them are larger than the other, it can't be horizontal or vertical. And then that means there's not really vertices or ends of major axis, minor axis. It's like they're the same thing. So you just add 3, subtract 3 from the center, both up and down, left and right. So that gives you all these different coordinate points. And then the graph would look like this. Of course, it's just a circle centered at 3, -2. But what about the foci? You should have come up with c squared equals 0, which means you can either think of this as there's no foci because you're not stretched left, right, up, or down, or you could think of it as that both of the foci are at the center. And so if they're at the right there at the center, then that just kind of works out. Like I think of this as no foci. It doesn't really have it because they're just centered right there and it creates a circle. Okay, so trick question. Hopefully you figured that one out pretty quickly. All right, so next up is without graphs, is trying to figure out all these different characteristics of an ellipse and how that can help you come up with the equation. So we're going to create an equation of an ellipse that has a major axis along the x-axis. So right away, that tells me that we are a horizontal ellipse, because if the major axis is along the x-axis, it's got to be stretched left to right. The length of it is 14. Okay, so think about that. If the entire length of that major axis is 14, then halfway there is your A. Halfway is 7. See, so if I say the entire major axis equals 14, then my A would just be a 7, and my A squared, which I'm going to need, is going to be 49. Okay, that helps us just make a quick little list of things. Now, what about the minor axis? The minor axis would be this up and down portion, right? So the up and down would be a length of 10. So that's 2 times B equals 10. And therefore, B equals 5, and B squared would equal 25. Okay, and then what else? So I've got my A squared, I've got my B squared. All I need to know now is the center. And the center is at the origin. It's at the coordinate point 0, 0. So here we go. This is going to be simple enough. It's going to be x squared over something plus y squared over something. And then it always has to equal 1 for an ellipse. It equals 1. Now, what goes on bottom? Does the 49 go here? Does the 49 go there? Remember, it's the A is always going to go in front with X as long as we did this correctly and figured out that 49 is larger, right? 49 and 25. And so the larger number has to go underneath the X since it is a horizontal ellipse. And the smaller number will go underneath the Y since that will be the minor axis up and down. And then that's it. That is your equation. Now let's do another one. Given the foci at these coordinate points. So remember, foci are going to help us understand what this value of C is. And if we're at -2, 1 and -2, 5, what's changing here? The Y value is changing. So now this is going to be a vertical ellipse. It's going to be up and down. The major axis endpoints are at -2, -1. So this is like -2, -1. And up here is -2, 7. So there's my major axis endpoints. So where's the center? The center's got to be right in the middle. Let's list that out. So the center is going to be right in we can do either the middle of the major axis endpoints or the middle of the foci. It doesn't really matter which we do, but notice that the x value is -2 on those, right? So what's halfway between 1 and 5? That is 3. And if you're not sure how I got that so fast, halfway in between is the average. So 1 plus 5 is 6. Divide that by 2, you get 3. All right, there's my center. Now, what are we going to do with these major axis endpoints? This is going to help us figure out the radius, the vertical radius. Well, the vertical radius is always b. So the entire major axis, all the way across, how long is that? It's double b. And if I go from -1 to 7, that's a distance of 8. Right? I don't have to worry about the -2s because those didn't change. So if that's the case, then b would equal 4, and b squared equals 16. All right, now what do we need? We've got the center, we've got b squared. All we need is a squared, but it doesn't tell us anything about the minor axis. So we have to use the value of c to figure out what the a value is. So what is the value of c from the center to one of the foci? So that from that 3 to that 5, that's just a 2. So c equals 2. C squared equals 4. And now I can say c squared equals, now which one is larger? Is it the a or the b? Well, obviously the b is larger if you look at that picture. So 16 minus a squared. Oh, I should have wrote down what c squared was. 4. All right, here, I'll just do it like this. 4 equals 16 minus a squared. When you solve that, I'll draw a little arrow up here. We're going to get a squared equals, if I bring the a squared over, subtract the 4, that equals 12. So a squared equals 12. Now, I don't need to figure out what a equals because the whole point is to figure out what a squared and b squared equals. So now I can set up my final answer. So I have x plus 2 for the center, quantity squared, over something, plus y minus 3 because of the center, quantity squared over something, equals 1. And then what's my somethings here? So the larger number, the a squared and the b squared, the larger one has to go under the y because that's up and down under the y, so 16. And then the 12 will go underneath the x, and there is your equation. All right, one more problem, and then we've got this all wrapped up. Now we're going to use the technique for completing the square. We did this a little bit with parabolas, and now we'll do this with ellipses as well. And that's just to help us put these things into standard form of an ellipse, and that helps us identify the stuff that's going on here with the center and all that. So first up is we need to get the terms that have x's together. So there's an x, 3x squared minus 12x, and then let's get the terms with y's together. So plus 5y squared plus 30y, and then we have this constant here, the 42. Let's just take that to the other side. So minus 42. Okay. The reason I have this line here is that tells me where your notes cut off, so I don't go past that line to make it easier when I'm doing my notes for you. Okay, next up is we cannot complete the square unless the quadratic term, the thing with the x squared, has a 1 in front. So what we're going to do is factor out a 3, and then that leaves me with x squared minus 4x, because I factored out the 3 from that. Now we can complete the square of just this. So let's complete the square. Half of 4 is -2. Half of -4 is -2. Square that, and you get a plus 4. All right, so let's add 4 there. Close my parentheses. Plus, now we're going to complete the square for the y terms. Again, you need the quadratic term, the y squared, to have a 1 in front. It doesn't. So we'll take a 5 out, and then we will say y squared plus 6y. Okay, so we factored out the 5. Now let's complete the square of this y squared term here. Y squared plus 6y. Half of 6 is 3. Square that and you get a 9. So we're going to add a 9. Close the parentheses. Equals -42. Now we've got to balance this. we're allowed to add anything we want on the left side as long as we add it to the right side. So what I'm about to do is wrong. Please don't write this down. This is wrong. Don't write this down. If I was saying this would make sense if you just thought, okay, plus 4, plus 9, that balances it, right? But that's wrong because this is not a 4. That 4 is being multiplied by this 3. So instead of a 4 that we added on the left, we actually added a 4 times 3. And that means 4 times 3 is 12. That, adding 12 would balance this 4. And this is not a 9, this is a 9 times 5. So 9 times 5 is 45, and that would then balance it. Okay, so hopefully you could follow what I was doing there. And then now we can start cleaning this up a little bit. We get 3 times. This now becomes a quantity squared, right? We factored this into a nice perfect trinomial. So it becomes x minus 2 plus, and then the 5 times something quantity squared. This thing becomes a quantity squared, which is y plus 3. We always take half of that number. Equals, and then we just add this stuff up. 45 minus 42 is 3, plus 12 is 15. Okay, and then the last step here is to get it in standard form for an ellipse, it has to equal 1. So since this equals 15, we're going to divide by 15. Divide each term by 15, and then we are finished. So you can treat this like it's a fraction that reduces the 3 and the 15. That now just reduces to, we have x minus 2 quantity squared over 5 plus, and then this one is y plus 3 quantity squared over, and this reduces 5/15 becomes 1 over 3, and then it equals 1, and there we go. We've got our standard form for an equation of an ellipse, and we used all these Algebra 2 techniques to help complete the square and get through that. All right, this is Mr. Bean signing off. Rock that mastery check, and I'll see you back in our next lesson, which will be the final one on conic sections.